So 4.7 is optimization problems. So it'll ask you like, what are the dimensions to optimize the volume or to make the maximum volume? It could also be the minimum as well. So that's what you're looking at in these problems. The way that I've laid it out in the notes, it literally tells you step by step how to do it, as well as like talking you through how you do it. So the very first part, one of the most common applications of calculus involves the determination of minimum and maximum values. Consider how frequently you hear, and you probably don't hear these a lot, but if you're going into engineering or anything like that, you 100% will hear it. Any kind of physics class, you will hear it as well. So consider how frequently you hear or read terms such as greatest profit. Now that one I'm sure you've heard. Least cost, least time, greatest voltage, optimum size, least size, greatest strength, and greatest distance. And again, you may not have heard of all of those, but some of these you'll use in a lot, like you don't even realize you're using it. So like your least cost, that's kind of like bargain shopping. Are you getting, the most bang for your buck or whatever? All right. So before outlining a general problem solving strategy for such problems, consider the following. So maximum volume. A manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimensions will produce a box with the maximum volume? So then it shows you your open box with your side lengths and your height. And then it gives you your surface area. Okay. Because the box has a square base. How do you know it has a square base? Because it has X and X. So both sides are exactly the same. Your volume. Remember, normal volume of a box is base times height. Length times width times height. So since our length and width are the same at X, we have X squared times the height. This equation is called the primary equation because it gives a formula for the quantity to be optimized. All right, so that's important. How do you tell the difference between a primary and a secondary equation? A primary equation gives a formula for the quantity to be optimized. So we wanted to have the maximum volume. So our primary is going to be our volume equation. Does everybody understand that? All right. The surface area of the box is S equals the area of the base plus the area of the four sides. So surface area is just that, the area of the surface. So each side of the box and the bottom, we don't have a top, so we don't have to worry about the top. You guys can see that formula underneath the picture. It told you that the surface area was 108. We know that the area of the base is X squared. How do you find the area of each side? Length times width, X times H, and there are 4 of those. So that's where this little formula under here comes from. Does everybody understand how I got that formula? So again, it's the area of the bottom, X squared, times the area of all the sides. And since it's a cube, all the sides are the same. So 4X times H. Because V is to be maximized, you want to write V as a function of just one variable. To do this, you can solve the equation That one that we just had, x squared plus 4xh equals 108. 4h in terms of x. I'm gonna stop there for just a second. We're gonna talk about that. All right, since our volume is x squared h, we need to get it in the same variable. That's all it's saying. You need to have it in the same variable. So they're gonna put it in terms of h instead of putting it in terms of x. Will putting it in terms of x work? Absolutely. It doesn't matter which variable you use. So you may do it a little bit different than your friend, and that's okay, just as long as you put it in one variable. So to obtain, if I solve this for h, what would I have to do? Talk to me about the steps. Subtract the x squared and then divide by 4x, right? All right, so that's exactly what this is going to say. H equals 108. You said subtract x squared and then divide it by 4x. So I wanted you to know where that came from.
Is this to have something to do with variables?
The what?
Is this to have to do with variables?
Yeah. All right, is everybody good? Yeah, we're not getting away from this. All right.
I just wonder.
Substituting into the primary equation. Produces, so here's our primary equation. We're going to change h into 108 minus x squared over 4x. What can I do? I'm just going to simplify it. Okay, so I can take an x there. I'm going to go ahead and distribute that x in. So I get 108x minus x squared, sorry, x cubed over 4. And then all they do is separate it out. So they do 108x over 4 minus x to the third over 4. Why do they do this? To make your derivative a little bit easier when you try to find derivatives. Okay. 108 over 4 is 27x minus x to the third over 4, which is 1/4 x to the third. So in your book, if you're looking at these notes in your book, they skip all of this and go straight from here to here. So I wanted you to know where all that came from. Is everybody good? All right. Before finding which x value will yield a maximum value of v, you should determine the feasible domain. Feasible just means what like works in the problem. So if we're talking about volume of a box, what's the littlest volume you could have? 0. And then the highest is going to be based on what you can fit in there, right? Does everybody understand that? So our feasible domain, so that is what values of x make sense in the problem, has to be greater than 0. The v has to be greater than 0. We can't have a negative volume. So that's all it's saying. You also know that x must be non-negative. Why? I can't have a negative side of a box, right? Does everybody understand that? All right. And that the area of the base, that formula is area equals x squared, is at most 108. Where'd that 108 come from? Okay. Everybody good? So here's your feasible domain. 0 is less than or equal to X. Less than or equal to, I'm gonna hold off for just a second. 108 is the area. We found that by doing X squared. We're trying to find X. How would I just find X on this? So there is your domain. So I didn't want to write just 108 square root 108. You guys wonder where it came from. So our values have to fall in there. If you get any answers that are outside of that, they're extraneous solutions based on the problem. So we just mark them out. So everybody got it? All right. To maximize V. Here you go, Haley. Find the critical numbers of the volume function on the interval 0 to square root 108. You know. Everybody good? All right, so that formula that we had. Yeah, X cubed over 4. How do we find critical numbers? Very good. Derivative set equal to 0. They do dv over dx. Again, just because you're taking the derivative of the volume with respect to x. I don't care if you don't put that. It's just there. And then what's your derivative? 27. Three x squared over 4. Yes. Okay. Again, if you don't know where that came from, we have a negative 1/4, and then we have to do 3x squared because of the top. So then when you put it together, you're going to get that negative 3x squared equals 4. And then what do we say we do to it? Set it equal to 0. So how do I solve this? You can subtract the 27. I'm going to subtract the 3x squared over 4 to make it positive. It works the same way. It's not a big deal. Okay, so I'm going to do 27 equals 3x squared over 4. How do I solve? Cross multiply. What's 27 times 4? 108. Equals 3x squared. How do I solve? You get x squared equals 36. What do I do now? How many answers are there to a square root problem? Positive 6 and negative 6. But what do we have to remember? The domain is 0 to square root 108. So what do you know? Okay. And they're going to explain that in this paragraph now. Okay, so I just explained it, but we're going to do it again. So the critical numbers are x equals plus or minus 6. So in the very beginning sections of this chapter, we were finding those critical numbers and we would have to put in those values to be able to find our max, min, whatever. Got it? But now we're basing it off of 0 square root 108. So you do not need to consider x equals negative 6 because it is outside the domain. Evaluating V at the critical number x equals 6 and at the endpoints of the domain. All right, so what was V? What was V? So 1/3 over 4. Let me make sure I got my calculator set up right. So what are my endpoints? What are my endpoints? 0. Why are you not typing in? And then I had positive 6. And then square root 108. Everybody see those? You got it? So I put in my V, so we plug it into V. We've been doing this, right? So it's not new. And I got 0, 108, and 0. So I wanted you to know where this came from. V of 0 gave us 0. V of 6 gave us 108. And then V of square root 108 gave us 0. So V is a maximum when X equals 6. And the dimensions of the box are 6 by 3. I'll show you where I got the 3 in just a second. Is everybody good? All right. You plug it into any equation. They plugged it into the surface area equation because we needed the H. We were looking for the H. So those are the two things that we have, the X and the H. So we couldn't plug it into the area. We couldn't plug it into the volume because the volume was, we could have, but we didn't know the volume. What we do know is the surface area. So 108 equals X squared plus 4XH. We know that X is 6. You guys could go back to where we solved it for H and just plug it in there if you wanted to. So we would do 108 minus 36 divided by that 24, and we get H equals 3. So that's where the 3 comes from. Again, your book does not give you that. So if you went back and looked at it, you would have no idea where, I mean, you would have to figure it out. All right, so let's go back over it. First thing we did was write a primary equation. Second thing we did was get it into an equation that had the same variable. Okay, we don't want two different variables. So that then we can take the derivative and find the critical numbers, plug in the critical numbers, and find either the max, or if we were trying to minimize, the minimum. Okay, so it's the same thing you've been doing, they just put it in word form. That's it. All right, in the last example, you should realize that there are infinitely many open boxes having 108 square inches of surface area. So we could change those dimensions as long as it added up to 108 to whatever we wanted to. To begin solving the problem, you might ask yourself which basic shape would seem to yield a maximum. Should the box be tall, squat, or nearly cubical? You might even try to calculate a few volumes to see if you can get a better feeling for what the optimum dimensions would be. Remember that you are not ready to, I should say, begin solving a problem until you have clearly identified what the problem is. All right. Guidelines for solving applied minimum and maximum problems. The first thing, identify all given quantities and all quantities to be determined. If possible, make a sketch. You guys already had a sketch on the last one. You're going to write a primary equation. What is that primary equation based off of? Read it. Whatever is going to be what? Maximized or minimized. So the last one of the maximum volumes, we write a volume equation for the box. Reduce the primary equation to one having a single independent variable. This may involve the use of secondary equations. relating the independent variables of the primary equation. Determine the feasible domain. Of the primary equation, that is, determine the values for which its stated problem makes sense. And then determine the desired maximum or minimum value by calculus techniques. Reagan. Guys, if I see you sleeping, I'm gonna write you up and send you out. We got it? I don't have time for that. Which points of the graph of y equals 4 minus x squared are closest to the point 0, 2? So then you guys see this little figure, you can see some distance formula down here. We're gonna talk about it all. Again, it all lays it out for you. The figure shows that there are 2 points at a minimum distance from the point 0, 2. The distance between the point 0, 2 and the point x, y. On the graph of y equals 4 minus x squared is. Remember that your distance formula, and I'm going to go ahead and put it up here because we're not writing anything up here. Oh, it doesn't matter. X minus x squared plus y minus y squared. You can have any, like, it could be the y's first and then the x's. They used to make you teach y2 minus y1 squared plus x2 minus x1 squared. I just do x minus x, y minus y. That's in order. You read left to right. It doesn't get messed up that way. All right. So the distance is the big fat square root. Your first x is 0 and your second one is x. So 0 minus x squared. Your two y's are 2 and y. So 2 minus y squared. Using the secondary equation, again, this one is your primary because what were we looking for? The closest to the point. So we're looking for the distance. Does everybody understand that? So this one is your primary. Using the secondary equation, the only other equation you have is 4 minus x squared. You can rewrite the primary equation. You don't even have to change this. You're just going to plug this in for y. So d equals the square root 0 minus x squared plus 2 minus 4 minus x squared. Be careful of this minus right here. Okay. Inside. 0 minus x is negative x. Squared is positive x. I'm going to clean this up. 2 minus 4 is negative 2. And then we have a negative x squared, which is a positive x squared. And we need to square that. When we square this, that means write it twice. So over here, I'm gonna work this out for you. I don't ever have to write it out, but just so you guys can see it. -2 times -2 is +4. -2 times x squared is -2x squared. -2x squared. And then x to the 4th. So down here, 4 minus 4x squared plus x to the 4th. Sorry, this should be x squared. I apologize. I said it, but didn't write it. And then clean that up. So we have just a 4. We have 1x squared minus 4x squared is -3x squared. And then x to the 4th. Doesn't matter what order they're in at all. Because D is the smallest when the expression inside the radical is the smallest. You need to only find the critical numbers. Of 4 minus 3x squared plus x to the 4th equal to f of x. And note that the domain of f of x is the entire real number line. Why is it the entire real number line? Because we're talking about a function and the coordinates can be either positive or negative, it doesn't matter, right? Everybody understand that? So your distance can be that way as well. So there are no endpoints of the domain to consider. So we wouldn't try to plug in negative to positive infinity. Okay. Moreover, the derivative of f so right now we're looking at f of x equals this. So what is your derivative? What's your derivative of f of x? And then they also factor it out. You do not have to factor it out. I just, if you look in your book and follow through or whatever, you're going to see that they take out a 2x. And get 2x squared minus 3. It flipped around. The reason they do this, to find our critical numbers, we're taking our derivative and setting it equal to 0, right? So we would have to factor it anyway. So what are your answers? What will the 2x cause? The 2x squared minus 3 equals 0. We're going to add the 3. We're going to divide by 2. And then we're going to square root. Remember, when we take the square root, there are 2 answers. She wasn't bothered anymore. She lied. So the derivative is 0 when x equals 0 and x equals positive or negative square root 3/2. Testing these critical numbers using the first derivative test. Verifies that x equals 0, yields a relative maximum. So what the first derivative test, what is that? Yeah, what is the first derivative test? So doing the chart, find the maximum in. Okay, so let's look at that really quick. So negative infinity to, what's our first one out of this? Okay, your next one is negative square root of 3 over 2 to 0, 0 to square root of 3 over 2, and then square root of 3 over 2 to infinity. Put in your first derivative. What was our first derivative? And then what's a number between negative infinity and negative square root of 3 over 2? You can make it anything. I can make it negative 100 because I know that that's going to work. Does everybody understand that? What kind of number did I get? It's negative 4e to the 6. Not a minimum, but a negative. If you don't know the square root of 3 over 2, plug that in. It's 1.2. I need a number between negative 1.2 and 0. Negative 1 gives us a positive. Between 0 and 1.2, 1 gives us a negative. And then I can jump into 100 as well, and that gives me a positive. So this one goes decreasing to increasing. So what's that? Increasing to decreasing. And then decreasing to increasing. Everybody got that? So from the first derivative test, x equals 0 gives a relative. Yes, ma'am. Or possibly the ninth, yes. In 2 seconds. Sorry, I'll just bear with me. Uh, 10/3/21. Okay. Okay. Thanks. Okay. That's literally the 6th time they've called me this morning. Like, I'm not kidding. Well, here's the thing. If it's related to my medical status, look it up. Look it up. It's on my insurance. It's on everything. They were just asking me if I was vaccinated. Like, when was your last shot? That's it. So I don't have to get a COVID test before I go. You have it. Look it up. Like, legit, look it up. All right. So verifies that x equals 0 yields a relative max. Sorry, y'all that are recording, I apologize that I had to do that. So I forgot I was recording. Whereas both, I don't even know where the pencil now. Sorry, y'all. Square root of 3 over 2 and negative square root of 3 over 2. Yield a minimum distance. So I wanted to show you that. So the closest points are going to be what? Is it going to be your minimums or your maximums? Is it going to be your minimums, closest, or your maximums? It's got to be your minimums, right? Minimum distance, not maximum distance. Everybody understand? So the closest points are square root of 3/2. The y value, when I plug that in, is 5/2. And negative square root of 3/2, 5/2. And again, the 5/2 comes from plugging it back into the formula. The very first one, y equals 4 minus x squared. So even on your test, sometimes it asks about the first derivative test, use it if you need to, or the second derivative test. That's just making those charts. That's all that is. Got it? All right, finding minimum area. A rectangular pages contain 24 square inches of print. The margins at the top and the bottom of the page are to be 1.5 inches, and the margins on the left and the right are to be 1 inch. What should the dimensions of the page be? So the least amount of paper is used. So what would our primary equation talk about if we're talking about how much paper we're going to use? I mean, it's up there. The area. And do we want big or little? Little. So dimensions should tell you length times width. Does everybody understand that? Your dimensions, length times width. So area. And it wants the least amount of paper. So minimized. How do we find this area? It gives you the formula, but tell me how you get that. So the area, that formula is literally right there, is x plus 3, y plus 2. Where does that come from?
So 1.5,
1 and 1/2 plus 1 and 1/2. So the top and the bottom margins add to 3. So it's the page, like the print, plus 3 is how big the page is going to be. Does everybody understand? And then the width is going to be the print plus 2 inches of margins. Got it? That's where the formula comes from. So the printed area inside the margins is, how much page can we have? 24, right? So just the print, XY, is 24. Everybody understand? All right, solving the equation for y produces y equals, how do I solve this for y? 24 divided by x. Substitution into the primary equation. Produces a equals. Now, remember, you could have solved this for x and done the same thing. It's going to give you the same answers. Everybody understand that? But typically we solve everything in terms of x. So I would try to keep x and not y. So area equals, the x plus 3 is going to stay the same, but I need to replace y.
Do you know how if somebody accidentally signs themselves up as a teacher and idiot, how to change it?
Can't you delete them out because you're a teacher and make them re-sign in?
Oh, I'm gonna go
Try
job.
that. Interruption 432. I can't say, she covered my class this morning while I dealt with that. I can't really say anything. It's a math program online, which I wish I had known about a long time ago. I'm not really using it this semester, but last year it like gives you problems. So like if you're solving equations, you can set it up where it'll give them 10 problems and they'll take it like a quiz. Or you can give them like you have to get 10 problems correct before you can stop.
It's like Delta.
Yeah, but it's not hard.
I like it.
I think Ms. Burkhart used a lot of Delta Math and calculus too.
In pre-calc, we don't have a lot.
She does all of it.
Oh, we would get a day off on Wednesday. We did it before.
But what I'm saying, it's like lower level maths. It's not like super high stuff. All right. Simplify this out. Remember you would double distribute. Is everybody good with that? I'm not gonna write this one out, but I'm gonna tell you what it is. When you double distribute, you get 30 plus 2x plus 72 over x. And because x must be positive, you're interested only in values of a where x is greater than 0. So to find the critical numbers, differentiate with respect to x. So again, we have to go ahead and multiply that out so it'll be easier to take the derivative. If you're going to take this derivative, I would suggest that you write it like this. So then your derivative dA over dx is what? Negative 72. Let's just go ahead and put x to the -2, and then we'll rewrite it. So it'll be 2 minus 72 over x squared. Is everybody okay with that? And note that the derivative is 0 when. So now I'm going to set that equal to 0. What would I do? You can, or I can add the 72 over x squared, which is typically what I'll do, so that my x squared is positive. But either way works. You're going to cross multiply. So I get 2x squared equals 72. Divide by 2, which means x squared is 36. So our critical numbers again this time are positive and -6. So again, the derivative of 0 when x squared equals 36, or x equals positive or -6. So the critical numbers are positive and -6, but you do not have to consider -6 because it's outside of the domain. And remember, our domain was that it just had to be positive, greater than 0. The first derivative test. Confirms that A is a minimum when x equals 6. Okay, so let's talk about this for a minute. What would we have to put in for like our first derivative test? Why? Okay, so anything less than 6 and greater than 6. And then when you plug that in, you'll see that it gives you a minimum value. So then we want to find the y. So we plug back in. Y was 24 over x, or 24 over 6. Which is 4. And the dimensions of the page should be, so go back, here are your dimensions of your page. This is the dimensions of the print. So what we just found was the print, we need the whole page. Should be x plus 3 which is 6 plus 3, or 9, by y plus 2, y was 4 plus 2, or 6 inches. All right, so those are the last two that like spell everything out for you. Got it? So that's the last one. Now it's just a regular word problem. Two posts, one 12 feet high and the other 28 feet high, stand 30 feet apart. They have it all labeled out for you. Don't freak out. They're to be stayed by two wires attached to a single stake running from ground level to the top of each post. Where should the stake be placed to use the least amount of wire? What are we trying to maximize or minimize? We're trying to minimize. What are we trying to minimize?
The amount of wire.
What represents the wire on the picture? Yeah, yes. You guys see in the picture, like if they don't give you this equation, how do you figure it out? Where is the wire in the picture? The equation tells you. Z and Y. So your wires are the ones that are staying there. Everybody got that? And then how do you find the total amount? You add them up. So that's where the equation comes from. I want you to know where it comes from because they won't always give you the equation. Everybody see that? So your primary equation is the total amount of wire. W is the wire. All right. But I need to get it in terms of the same variable. Same variable. So what are we looking for about the wire? But what do we have to know about the wire? How long it is. That's the distance. Does everybody understand? So we need to know the distance. How do we find it? How do we find the distance of Y? The length of Y. Yep. Does everybody see that? They set it up into right triangles to find Y. We're going to do Y squared equals. How do we find Y? Perfect. We're going to go ahead and solve that for Y. How do we do that? Guys, come on. This is algebra. Square root. So Y is going to be the square root. I'm going to go ahead and write it out. 144 plus X squared. That's the easy one. How do I find Z? So Z squared is going to equal what? 28 squared plus, not 30, but 30 minus X squared. I'm going to go ahead and clean that side up before I take the square root. What is 28 squared? Square this, so 30 times 30 is 900. You're going to multiply them by themselves. 30 times negative X, and then times 2 is negative 60X. And then negative X times negative X is a positive X squared. Then I'm going to clean it up. 784 plus 900 is 1684 minus 60X plus X squared. And then you're going to take the square root. So we had a primary equation, W equals Y plus Z. we made secondary equations. Both of these are secondary equations so that I could get it in terms of X. Everybody see that? So now I'm going to rewrite it in terms of X. What did Y end up being? And then we're going to add, what did Z end up being? Once I get it in terms of X, what do I have to do then? Two things. What? Not set it equal to 0, but derivative equal to 0. So that's 1. But before I do that, what could happen within my critical numbers? What? What could happen within my critical numbers? What's happened a couple times? It's outside the domain, but I don't know what my domain is. So that's the second thing I need to do. What is my feasible domain for this wire? How long is it between the posts? I can't have wire longer than it is between the posts, or the distance between the posts cannot be greater than 30. So less than or equal to 30. So now we're going to differentiate. It will be easier to differentiate if we make it to the 1/2 power.
That's square root. Like we were used to before you did the root.
The only way you'd be able to square it if it was like x plus 4, x minus 4. Like something like, or x plus 4 squared, something like that, but you can't do that. What you're thinking about is taking the square root of 144 and the square root of x squared. You can't do that because they're together. If they were separate, you surely could. All right, so find the derivative. The derivative of w with respect to x. What are we going to have? Start with the first one. 1/2. To the negative 1/2, and then 2x. Everybody good? Let's just look at this for 1 minute. What can I do? Yeah, the 2's will cancel out, and eventually I'll move that down, but I'm not going to do that yet. All right, plus the next one is the same exact way. We're going to have 1/2 1684 minus 60x plus x squared to the negative 1/2, and it's still going to be times, sorry, not 2x, but what? Yep. And if you want to write it that way, that's fine. What can I do there? Half of 2 and half of 60, right? You can do the same thing. It's just as long as both of them are. So your 2 will go away, this will go away, and this will become 30. So now I'm going to clean it up. The only thing I have left on top is this x. On the bottom, the square root of 144 plus x squared. The next one is plus. I have x minus 30 left on top over the square root of 1684 minus 60x plus x squared. How do I find my critical numbers? Equal to 0. It looks like it's going to be crazy. It's not bad at all. Okay, it's not bad. What do I do? Heck, no, we ain't making a common denominator. We are going to subtract and cross multiply. You tell me what your common denominator will be. Yeah, you eventually kind of do, but we're going to cross multiply, so it makes it a little bit easier. So we're going to have x over the square root of 144 plus x squared plus x squared. And we're going to subtract x minus 30 over the square root, blah, 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 blah. Y'all are okay if I don't write that right. Then because I have those square roots, I can cross multiply, but I don't even want to deal with square roots. So I'm gonna square everything and that'll take that negative away in the front. So if you're worried about that. So what that will give me is x squared. On the bottom, it'll take away that square root. On the top, you're doing x minus 30 squared, which will be x squared minus 60x plus 900. On the bottom, it'll just be all of that 1684 minus 60x plus x squared. It looks rough, it gets better. Okay, looks rough, gets better. So we do have to cross multiply, which means you'll distribute your x squared in here. So 1684 x squared minus 60x cubed plus x to the fourth. On the other side, you're going to multiply everything by 144 and then everything by x squared. So 144 x squared. 144 times negative 60 is negative 8640x. 144 times 900 is 129,600. And then multiply everything by x squared. So plus x to the fourth minus 60x to the third plus 900x squared. Realize if it's the same on the left and the right, it's going to cancel out. Okay. So if I move my x to the fourth over, it's going to cancel out. If I move my negative 60 over, it's going to cancel out. The only thing left on this side is 1684x squared. On the other side, add your like terms. 144 plus 900 is 1044 x squared. Then we have minus 8640 and 129,600. We're going to get everything equal to 0 because we want to set it equal to 0 so that we can factor it. So I'm going to move everything to where the x squared is going to be positive. So I'm moving every bit of this over and it's going to give you 640 x squared plus 8640x. You guys can solve this using your calculator. I'm going to go ahead and factor it for you. But like I said, you can solve it, put it in y equals and find your, like, put one side in y1, the 0 in y2 and find your x-intercepts. They're not big x-intercepts. They actually end up being small numbers. But I'm going to go ahead and tell you how to find them. We can factor out 320, which gives us 2x squared plus 27x minus 405. How would I factor this inside? Slide and divide. I'm not going to make you do that. You know how to slide and divide. When you do slide and divide, you get x minus 9 and 2x plus 45. So the first one gives you 9. The second one gives you negative 45 over 2. Are my critical numbers okay? Yeah, I gotta have 0 to 30, right? So that one's not gonna work. So then I'm gonna plug in my endpoint, my critical number, and my endpoint. and I'm plugging it into the original equation. Again, you can do the derivative. It doesn't matter. It's going to make it fine. When you plug in 0, you get 53.04. So this is your original W equation. I would plug it in right here near this squiggly line. Get 53.04. When I plug in 9, I get 50. When I plug in 30, I get 60.31. Go back to the beginning. What did we want to do? Least. Which one is the least? That one produces the least. 50 is the least amount. And then you're done with the problem. I know it's crazy. Now the work is, it's long, it's just not hard work. You know what I'm saying? It's not like the other ones where you're setting up equations crazy. In each of the first 4 examples, the extreme value occurred at a critical number. Although this happens often, remember that an extreme value can also occur at an endpoint of an interval, such as the next example. When I get through. All right, 4 feet of wire is used to form a square and a circle. How much of the wire should be used for the square and how much should be used for the circle to enclose the maximum total area, the maximum total area? So what are we trying to do? First thing I want to know is max or min? I'm maximizing, and what am I maximizing? Maximizing the area. What do we have figures of? Circle, how do we find the area of a circle? It's on there, pi r squared. So we're doing a circle, pi r squared, plus we're doing a square, x squared or side squared. All right, so that's your primary equation because that's what we're trying to maximize. What is your secondary equation? What else does it talk about? That very beginning sentence, what does it say? So where is that wire at on the square? Around the outside, right? Yeah. You're saying exactly what I need you to. Around the outside, what is that called? That's exactly what I'm looking for. So your secondary equation is perimeter. Okay, so how do I find the perimeter? For the square, it's 4x. What about for the rectangle? I mean, for the circle? 2 pi r is the circumference, 2 pi r. Or pi times your diameter, whichever one you want to use, it doesn't matter. We want this in terms of x, so what do I need to solve for? What do I need to get rid of in here if I want to put it in terms of x? The r, so I need to solve this for r. Does everybody understand that? These are the steps that you go through. So how do I solve this for r? What's the first thing I'm going to do? And then? But it told us something else. We have 4 feet of wire. So if I only have 4 feet, where would that go? Would that go in P, X, or R? P, because it's the perimeter. That's all I'm using it for. So this is actually going to be 4 minus 4x over 2 pi, or I could even reduce it to what? Try again. 2 minus 2x over pi, just to make it a little bit easier. All right, so now we're going to change our area formula. Pi times, instead of r, we're going to have 2 minus 2x over pi squared, and then we're going to have x squared. All right. I'm going to leave this pi for a minute. Up here, I'm going to square this. 2 squared is 4. multiply them together and then multiply by 2. 2 times -2 is -4 times 2 is -8. And then a positive 4x squared. Again, for this, 2 minus 2x, 2 minus 2x. I just put that all down here, combined up. And then on the bottom, you would have pi squared plus x squared. What can I do now? You can cancel out one of the pi's. What else do I need to do?
Take a common, various common thing.
I wouldn't take anything out just yet. I would probably try to get a common denominator. Do you have to? No. Why do you not have to? Because what is pi? It's a constant. So when I take the derivative, it doesn't really hurt anything. Does everybody understand? So I'm just going to clean it up that a equals 4 minus 8x plus 4x squared over pi plus x squared. So now that I've got it in terms of x, and again, you don't have to reduce it at all if you don't want to, but know that you're going to have to find that derivative. How do I find the derivative? What is pi? It's a constant, so I'll go ahead and pull it out. Now just find the derivative of the top. What's the derivative of the top? -8 plus 8x. What's the derivative of x squared? 2x. That's it. What do I need to do now? Set it equal to 0. What do I do? And then? Or just multiply by pi. So I get -8 plus 8x equals -2 pi x. Add 8. I'm gonna put my x's together. Remember, pi is just a constant. So this is like -6.14. Don't stress out about it. It's not really 0.14, but y'all get the point. So this is just a number. I need to get my x's together. So I'm going to subtract the 8x. So I get -8 equals -2 pi x minus 8x. How can I fix this? No, yeah, take out a negative. I would take out a -2x. Which leaves me with pi plus 4. Crazy, isn't it? Keep going. What do I do? And -2, right? Is everybody good with that? What can I do now? Just to make it look easier, what can I do? These all cancel out. So I'm at x equals. I can either put it straight into my calculator, or I can reduce this -8/2 into 4 over pi plus 4. And I get what? 0.56, right? Y'all are doing just fine. Don't stress out. I found my critical value. Does it fall within my range? Because I didn't do a domain. What is my domain? Not 0 to 4. You're close though. What did X deal with? What was X gonna be, right? So if my perimeter is 4X, what is the only value that I can have? That's my 0 to whatever. So your perimeter of your square is 4X. I have 4 sides, right? So just one. Just one. Doesn't matter because it fits. Does everybody understand that? Even if you would have screwed up and put 4, would you still be okay? Yes, the problem is you need those 2 endpoints so that you can do the perimeter of 0, the perimeter of 0.56, and the perimeter of 1. 0 is 1.273. 0.56 is actually going to give you 0.56. And 1 is going to give you 1. We wanted to maximize. So there's your maximum. That's a good question. So if you just have 0, what does that mean? For what? For the square. You are absolutely right. Just use it on the circle to maximize our area. Is everybody good? All right. What I want you to do for me is try these 2. Try them on a separate sheet of paper. Don't try them on your notes. We will go over them. I don't think that your homework will necessarily need them, but we'll go over them on Thursday. If I can, I'll try to record it for you, but I doubt that's going to happen today. Everybody good? All right.